Okay, ladies and gentlemen, this is the Investigation 2 video for looking for Pythagoras. This is the first video on this particular subject in this brand new book in 8th grade math. What we're going to look at today is Investigation 2.2, which is on pages 20, and you'll be doing ACE problems 4 through 34, and you'll also be doing Investigation 2.3 in this investigation. And investigation 2.3, you're going to be on page 22, A through C. And then the ACE problems 35 through 41, 43 through 46, and 49 through 53. This is a double header. If it takes you a couple of days, that's understandable. Let's go ahead and get started on the lesson. Now, here's some notes you need to get down. One is squares. Now, a square is any number times itself. So, for instance, if I have 2 squared, it actually is 2 times 2, right? It represents a 2 by 2 box. And the value of 2 squared is 4. Likewise, if I've got 5 squared, it's actually equal to 25, because it's actually equal to 5 times 5, which is actually can be represented as an area, making a square box of 5 by 5. It would have an area of 25. So we use squares all the time in real life when we talk about square feet or square inches. This is basically talking about, well, what values do you get from that? Now, a square root is the exact opposite. The square root asks you, okay, if I've got 9 here, and I want the square root represented by this little squiggly thing that looks a little like a division sign but isn't. If I want the square root, it's asking me what number times itself would give me 9. Okay? So, the answer, of course, is 3. That 3 times itself, okay? 3 times 3 would equal 9. The square root of 9 is 3. Okay? So when I ask you the square root of, say, 25, you ask yourself what number times itself is going to give you 25. And the answer, of course, is 5. So make sure you get these 2 topics down, because we're going to be referring to them a lot down the road. Okay? Okay. Next one, Pythagoras. Okay, the Pythagorean theorem. It is the relationship of 2 shorter sides of a right triangle compared to the longest side. And it wasn't first developed by, but it was made popular by a guy named Pythagoras, who was born around 500 BCE. He believed that the universe revealed itself in numbers. It was part mathematician. He believed in math, he believed in numbers, he believed in logic. He was also kind of religious. He believed that the gods and the universe and all of these mystical things all express themselves through golden ratios and golden numbers. And he thought that music and art and science and math, all of these things could be expressed purely by the same mathematical principles. And he stumbled upon something called the Pythagorean theorem. And this is the Pythagorean theorem. A squared plus b squared equals c squared. Okay? And you need to copy this stuff down big time. If we have side A and side B, they are referred to both as legs. And C here is referred to as the hypotenuse. Okay? The hypotenuse. Really fancy long letter. Fancy long term. But it basically means that longest side in a right triangle. And what he predicted was that if you found what A was and squared it, and you added it to B, also squared, you would get C. Okay? And if you found the square root of C, if you took those two numbers, combined them, and then found the square root, you every single time could predict the length of that longer side. So here's my example. I have a triangle here with a side of 3 and a side of 4. Okay? And you can go ahead and, use a ruler if you want and try measuring this out. It's going to be true every single time. Okay? If I have a 3-inch by 4-inch triangle, and I want to know what this mystery side is, we do 3 squared, which gives me 9, plus 4 squared, which gives me 16. And you add those two together and you get 25, right? But remember, I want to find out what this number is. So what I have to do is take that 25 and find the square root of it. And the square root of 25 is 5. That as long as you know what those two shorter sides are, you can predict what the longer side is. So what this really means is if we have any two sides of any triangle, we can predict the third side every single time accurately. And for the Greeks, this completely blew their mind. It completely changed how they thought about math and the universe, and it's something that we still use every single day in space travel, in science, in satellites, in trajectories, in airplanes, in rockets, in everything. It's a pretty big deal. All right. So they're going to have you do this thing where you try to find missing sides using dot paper. Now the dot paper trick goes like this. If I have a square here, right? Okay. We know that this is a 2 by 2 square, right? Now let's say if I take a triangle here and extend it on this side. I have a length of 1 right here, right? I have a length of, oh, that's a bad example. I've got a length of 2 right here. I want to know, what's this length going to be? Well, I know that 1 by 1 gives me a value of 1. I know that 2 by 2 gives me a value of 4. So that means that this side right here, okay, if I extend it out, okay, if I want to know what this side is right here, I know that it's going to have to be equal to 4 plus 1, which gives me 5. But this side right here is not going to be 5. I know that the volume of the whole thing is going to be 5. But if I want to find that missing side, it's actually going to be the square root of 5. Now this is a tricky idea. Okay? Let me give another example. If I have a side that is, say, 2 by 2, I know this part here is going to be worth 4. I know this part right here is going to be worth 4. But I want to know, what's this part going to be worth? Well, I know that 4 and 4 together are going to give me 8. Okay? And that this missing side right here is going to be worth the square root of 8. Okay? It's true every single time. Now, if that seems a little complicated, ask me for some clarification, ask your neighbors for some clarification. All right, your practice, once again, is for investigation 2.2. You have to do problems 4 through 34 in the ACE problems. It's going to seem like a lot. It's not really. And then you'll have to do problems 35 through 41, 43 through 46, and 49 through 53. All right, ladies and gentlemen, remember if it takes a couple of days, that's A-OK. Have fun.